Currently, we are in week 3, is it? So, when we are in week 3, let me open again. Taking open. Okay. All right. So I will share a screen. I will share my screen. All right. Currently, we are in week 3, and then next week you will have your first quiz. Quiz 1 on next week. So I will tell you whatever will be asked during the quiz, what is the format, and so on. So I will explain to you later. And then after that, on week 5, before the midterm break, we will have lab 1. Okay, so that's all I just want to explain to you. Hopefully, by covered today's topic, I think you are ready to do your lab 1. Okay, so this is the thing. So I will proceed with the flashback what you have learned on last week. Okay, during the class on last week, I give you some introduction to control system engineering 2, and then I give you some explanation what is the definition of the control system. I believe you are familiar with this one because you have learned this one on the previous semester. Okay, and after that, this is example of processes, plans, and systems. Okay, right. So from the system, when I told you before, this is a system, and then you can convert to the block diagram. And then after that, from the block diagram on the control one, you transfer or you convert the block diagram, which is obtained from the system to a transfer function. And then after that, for this semester, you will convert the system in state space form. State space, yeah? Okay, so this is the general equation for the state space x dot equal to xt plus but and yt equal to cxt plus dut. And then the difference between the transfer function and the state space, the transfer function in time domain. Okay, however, you can see that the transfer function in frequency domain. Okay, you can see the difference clearly. Transfer function in frequency domain, however, the state space in time domain. However, later on, you will learn how to find the relationship between the transfer function and the state space. Okay, so this is the advantages of the state space. Okay, MIMO is a system, and then you will learn about the state space structure. Okay, so we already complete to do the state space structure in control in the previous class, and then today we will proceed with the second part lah. Do the modeling of the dynamic system, which is want to convert the system, electrical and mechanical system to a state space form. Okay, so we will focus this one on this by this week, and then by next week we will focus on number 3, signal flow graph for the state equations. Later on week number 5, on week number 5, you will do the simulation on the model system using the MATLAB simulator. Okay, so this is the thing. All right, so this example of the state space equation, and this is the tables are really important. Okay, so now we proceed with the today's topic. The today's topic is, I need to close this one because so many things here. Okay, so now system modeling. We go to the second part. Before I proceed with the system modeling, I would like to give you some overview. The topic that I will cover in this class, because the rest of the topics will be covered by Dr. Siti Mahanis lah. All right. So what you need to do is this is the thing that I will teach you for the 7 to 8 weeks. Okay, 7 to 8 weeks. In this case, you have two types of system. You have electrical. This is example of the electrical system, and then you have the example of the mechanical system. And then what you need to do, you need to convert these systems into differential equation. Okay. After you convert this system into two differential equations, later on, then you can obtain the state space equation. Okay. After you obtain the state space equation, you do the analysis. Okay. From the analysis, you can convert the state space equation into several forms. Okay, there are so many forms that you can convert. I think five of them, and then you will learn how to convert the state space into these forms. Okay, after later on, based on the forms, you can design a controller. Okay, to the system. In this course, you will learn two types of the controller: pole placement controller and also observable controller. And you after that you need to do some analysis based on the controller implementation. Okay, so this is the thing that I will teach you during in 7 to 8 weeks of the lecture. For today, I will focus on this part only: how to convert from the systems which is electrical to differential equation, and after that how to obtain the state space. So this is the objective for the class today. Any question before we proceed with the lecture? I believe it's too early to ask it. So go to the next slide. So this is our objective. Want to convert electrical or mechanical system, and then after that to convert to the differential equation, later on convert to the state space equation. Okay, so this is the example. This is the example. All right. Example 1. An RLC circuit shows the voltage as the input and the current across the inductor as the output. This is RL circuit. Okay. Voltage is the input, and then the current across the inductor as the output. Use ILT, it means that the current across the inductor as the state variables. And then determine the order of the system. Firstly, you need to determine the order of the system. Next, you need to obtain the state space for the circuit. All right. So to answer the question number 1, you must have this table in order to answer the question. Okay, you must have this table in order to answer the question. All right, so we try to find the keyword in this question. Use ILT as the state variable. Okay, so firstly you need to find how many components in this circuit. There are two components. The components are resistor, and the second component is inductor. Okay, so you need to, based on the circuit, I need to use this formula only. Okay, this formula only. And then we try to look at the keyword inside there. Use ILT as the state variable. Okay, so what you need to see for the inductor here, you have two options in order to determine your state variable. Okay, you have Vt Ld it over dt, and also Vt equal to Ld square Qt over dt square. If you still remember that, the state variable, how you want to determine from the previous class, you need to find the differential, the derivative parameters from the table formula. However, in this case, you have two options. You can use dit over dt, or you can use d square qt over dt square. But the question already asks you to use ilt as the state variable, so you just need to use this one only. So this is how we want to determine which formula that we will need to use to solve the question. Okay, for the resistor also same. Okay, the most important thing is for the inductor and capacitor. You need to determine you want to use this one example for the capacitor, or you want to use this. Depends on the question. Okay, so now we already know what is the formula that we need to use. Okay, so the formula that obtained from the table, so I do the short list. Okay, based on the table, there are three parameters, one, two, three. So I shortlisted the formula. So the first formula is VR equal to RIT. The second formula is the IT equal to 1 over R VRT. And finally, VLT equal to LDILT over DT. So this is the formula that I already shortlisted from the table formula. Okay, before I proceed, the first question, determine the order of the system. This one already explained during the previous class. So I would like to call as anyone. I would like to call Faiz Najwan. Can you tell me what is the order of the system? Faiz Najwan. Based on these three shortlisted formula, can you tell me what is the order of the system? Faiz Najwan bin Nur Muhammad Zakari. Are you here, Faiz Najwan? Are you there? Let's see. Any chat? No. Faiz Najwan is not here. Faiz name already in the meeting. Lavenia. So what is the order of the system, Lavenia?
Second order.
Okay, you tell me second order. Okay, that's your answer. So I will try to call others. Syahmi Akil, Muhammad Syahmi Akil. What is the order of the system, Muhammad Syahmi Akil? And also I would like to call Muhammad Khalid Ahmed. What is the order system? Okay, Ruslin, tell me first order system. Okay, so can you tell me, Ruslin, why this is first order system, Ruslin?
Because the highest of the power of the IDT is 1.
Okay, thank you, Ruslin. Roslyn, alright. So you can see that uh, the numbers of the differential parameter in this shortlisted, okay, shortlisted formula, the numbers of the differential parameter only one, okay. So that's why we can tell this is the first order of the system. Okay, so the order of the system is the first order system since there is only one differential parameter in the formula. Okay, so get ready others. So I will keep asking during the lecture. Let's say if I call anyone that and they did not answer, or the student did not answer, I will consider the student is absent. Okay, so I will take note the name and I will consider the student is absent, although the student fill up the attendance form. All right. Okay, so uh, okay, I would like to ask. Uh, Muhammad Khalid Ahmed. Muhammad Khalid Ahmed, are you there? Muhammad Khalid Ahmed, at least I need some response from the chat box or anywhere during your microphone and so on. If not, I will consider you are absent. I would like to call Ari Mugen. Are you there, Ari Mugen? Davendran? Are you there, Davendran? Okay, Ari Mugen. So, why we name ILT as XT? This is from the previous lecture. I already explained to you why I put XT equal to ILT, Arimugan. Because some of the students asked me to teach a little bit slowly, so I will do the teaching something like that. Okay, so anyone would like to help Arimugan? Why we name XT equal to? Because it is the input. All right. Anyone would like to comment based on the Arimuga answer? Okay, so Roslyn said that because xt equal to dx over dt, derivative. That's correct. Okay, so that's why we name xt equal to ilt because based on the differential parameter here. Thank you, Rashid, and also Roslyn for the answer. Okay, so based on the state space equation, okay, this xt, what is the name of the xt? Okay, we have ut as the input. If I can copy, if I can copy, need to stop presenting this one. I need to copy first. Control E. And I need to share my slide again. Okay. All right. So now we have xt equal to ILT. Okay. But what is the name of the xt actually? Indeed, based on the state space equation. The state space equation is x dot t equal to axt plus but, yt equal to cxt plus dut. Yep, the answer is correct. State vector. Xt is the state vector, or we also can call xt as the state variables. And then x dot t is the differential of the state vectors. All right, thank you for the answer. Okay, so the answer is the first order system since there is only one differential parameter in the formula. And then the state space for this circuit. Okay, so now we go to the second question. The second question is obtain the state space for the circuit. Okay. Obtain the state space for the circuit. Firstly, the step, you must understand the step, how to solve it first. So firstly, you need to obtain the KVL equation. Kirchhoff voltage law equation for this circuit. Okay, firstly. So the Kirchhoff voltage law for the circuit is Vt minus Vr minus Vl equal to 0. Okay, so this is the Kirchhoff voltage law for this RL circuit. But from the formula 1 here, and 3, okay, hence Vt, so Vr will replace with the Rit. So that's why we need to shortlist this formula, because it will be easy for us to do the replacement in the KVL or KCL equation. Okay, minus with L dilt over dt, since this equation equal to VL. So VL equal to L dilt over dt. Okay, what's next happen? So this one need to, okay. And then after that, after we complete with the KVL equation, we need to proceed with the KCL equation, Kirchhoff current law. In this Kirchhoff current law, KCL, we know that this is the IT, right? IT also same with the IL. The IT current actually is the same current that going through the inductor. So that's why we say that IT equal to ILT. Okay. Replace 5 to 4. Then we get Vt minus RILT minus DILT over dt equal to 0. So why we need to do replacement in 5 to 4, okay? Because if you can see that, we just need in the equation the parameter that varies with time, okay, only have in terms of ILT only. So I would like to explain to you what is the meaning of that. You can see that this is IT, okay. R is a fixed value because this is a resistor value. L is a fixed value. This is the fixed value, so this is the inductor value. However, the value of I is changing throughout the time because you can see in the bracket of T. So it's not fixed. It will depending on time. However, you can see that the xt here must be only in terms of ILT only. So you can see that this is in terms of ILT. Okay. Vt is the input. You not need to disturb them for the input. But this one you did not have any ILT term here. So you need to replace this IT with the term that relate to the ILT. So that's why we do the Kirchhoff current law, KCL, and we see that, oh, actually the IT actually equal to ILT. So that's why we just replace equation number 5 to 4. Now you can get that Vt minus R ILT minus L DILT over dt equal to 0. So you can see that all the term of the current now in inductor form IL. So what after we have this kind of the standard form, we can stop and we need to rearrange equation number 6 become to this form, the state space form. So how we want to do it, I will explain to you. So this is the base on the equation number 6 from here. This is based on equation number 6. And then we try to rearrange the equation number 6. So we just put it into the order. L dilt over dt equal to negative rilt plus vt. And after that, we just need to make sure the title equation must only have the differential, did not have any parameter here. So that's why we need to divide by L. Everything is divided by L. So finally, we have this kind of the equation. So if you can compare that, this one actually refer to x dot t, negative r over L actually refer to A, ILT equal to xt, the B matrix actually refer to 1 over L, while UT is the input refer to the VT. So if I can highlight here, x dot t, this one, A, xt, BUT. So you can say that this form already in the state space form, which is in x dot t equal to xt plus BUT. Okay, so what's next that we not complete yet? Now we already complete with the x dot t, xt plus BUT. So what is the next equation that we need to solve? Okay, Ahmad Abizar, what is the next equation that we need to solve based on the state space equation?
CX plus BUT, CXT plus BUT.
Okay, that's correct. So actually, that equation refer to what equation? YT normally refer to what? Ahmad Abizar. The symbol of YT normally refer to what? What thing?
Output vector.
Output, right? That's correct. So YT actually refer to the output. Thank you. So to solve this, the second equation, we need to look at the question again. The question said that the current across the inductor as the output. So it means that the current across the inductor is the output. So you need to read the question carefully, because in the question, they are divided into two parts. Information. The first information about the x, to get the x dot t equal to x t plus BUT equation. And then you need to find the second information, how to get the YT equation. So in this case, we said that the current across the inductor as the output. So look at how to solve the YT. Okay, so you can say that the output is the current across the inductor. Hence, the output equation is YT equal to ILT. Is it? Okay, so this case, we can compare this equation to the state space that we obtained before. We have this one, our xt equal to ILT, is it? So you can compare. This is the YT, same thing. Our C equal to 1. Since 1 multiplied with the ILT, you will get ILT, the same value. So the XT equal to ILT plus, because the rest is nothing here, so we can say that the D value equal to 0. 0 multiplied with VT will become 0. Nothing here. Okay. So finally, we get the state space equation for the RL circuit. This one, the ILT over dt equal to minus negative RL ILT plus 1 over L VT, and YT equal to 1 multiplied with the ILT. So this one actually refer to the X dot T equal to AX plus BU, and this is Y equal to CX plus with DU. However, the D equal to 0, there are nothing here to show lah. Okay, so now we already done for the RL circuit. So the next exercise will be on the RC circuit. So what I need you to do, please take your pen and pencil, okay, and paper, and please help me to solve these examples. Because in order for you to familiar how to do the modeling from the system to the differential equation to the state space, you must do practice a lot. Okay, once you are okay with this thing, I believe you are okay for this control systems engineering too. So you not need to tiru lah your friends during the exam as yang kamu buat sebelum ni. Okay, because during control 1 I can find maybe many of you do cheating lah during the exam. Okay, hopefully, however, when most of them do the cheating, however, the answer is wrong. Okay, it's too bad and so sad. Okay, so please do exercise and familiar with these steps to solve the question, and you not need to cheating during the exam. Okay, so firstly, example number 2. An RC circuit shows the voltage as the input. Okay, just take a note, voltage as the input and the voltage across the capacitor as the output. Use VCT as the state variables. Firstly, you need to determine the order of the system and obtain the state space for the circuit. Okay. As I mentioned before, what you must have before you proceed to solve this kind of question. The first thing, what you must have. Yep, you must firstly, okay, Sean, that's correct. You must shortlist the equations first. Okay, so before you shortlist the equations, you must have the table. Okay, have the table. But you must have the table. Okay. For the capacitor, why we need to use this one instead of this Vt equal to 1 over CQT? Why we did not use Vt equal to 1 over CQT only? Why we use this formula for the capacitor? Firstly, because we have resistor and capacitor, so that's why we just look at these two components. Alright, so the question again, why we just need to use this one, not this? Okay, anyone?
dA over dt derivative.
Yep, but yes, that's correct. So because this is the derivative lah. And then also you can see the keyword here, use VCT as the state variable. So this is the state variable, VCT over dt. Okay. Alright. So in order for you to, firstly because I can see that there is a comment that capacitor as input. Okay. Remember that in the circuit, you must know what is the input, what is the output. Normally the battery will be always the input. Okay, the battery always the input. And then after that, this is the components in the circuit. Okay, and then after that, you must know where is your output. In this case, the output for this circuit is the voltage across the capacitor, because I already tell you in the example. Right? So you must familiar to your system. You must know that where is the input, where is the system, where is the output. The input is the VS, the battery. The output, you must look at the question. In this case, it said that voltage across the capacitor, and the system is the overall here. This is your overall system. Okay. And then after that, this is the normal part. Okay. So in this case, thank you for the answer. Next, we do the shortlist. We shortlisted the formula. How many of them? There are three. We have VRT equal to RIT. Right. This one, I need to change the slide a bit. Okay, this is correct. Okay, so this is the three formula. All right, so I would like to ask again, any one name across Muhammad Nazrul Shawal. Can you tell me what is the order of the system, Muhammad Nazrul Shawal?
This is the first order
First order. Why Muhammad Nazrul?
because the highest number of highest power of the derivative is 1.
Okay, because the only one differential parameter in this case. Because this one there is no differential, no, only one. Only VC is the differential parameter. That's why we call first order of the system. Okay, so now as usual, we need to compare. We need to find this state space. Need to find this one. So after that, to answer the question number 2, so we need to find the KVL. Okay, so as usual, we say that VT is the input. All right, VT is the input minus VRT minus VCT equal to 0. Same thing, same step. And then based on the formula, we just need to do the replacement here. VT minus RIT minus VCT equal to 0. Okay. So based on the information you have here, what is the parameter that we need to change? Is it we need to change VT? Is it we need to change R? Is it we need to change RT? Is it we need to change VCT? Because I will give you some example from the previous. Oh, not this one. Yep, that's correct. We need to change IT, is it? So IT we need to change in what form?
IN.
Yeah. Okay. Once again, 2. Since our XT is VCT, so our reference parameter or our state vector must be in VCT. VCT. So this IT we must change to VCT. So how we want to do it? We know that from the KCL, so that's why we must have KCL equation. From the KCL, we know that IT here, actually the same current that cross the capacitor. So based on this equation that ICT also equal to C dVCT over dt. Alright, so we replace 5 to 4, then we get Vt equal to minus RC dVCT over dt minus VCT. So this is the step, how we want to solve it. Okay, so is it we already have a complete equation for x dot t equal to xt plus but based on equation number 6? Yes, that's correct. Already yes, because, okay, Edward, VCT is that this is our state vector. Okay, so this term already in VCT, this term also already in VCT, and this is VT. VT just let it be because this is input. So we just need to change the parameters, accept that accept that input. Okay, accept input, but the rest, the other parameters, we must change into the state vector parameters. Okay, so in this case, our state vector parameter is VCT. So this one already in VCT, and this one already in this VCT. So complete. Okay, after that, so this one, oh, this is the repetitive slide. Okay, so now from 6, so we do the rearrange as usual. We do the rearrange again, similar thing, and make sure this is in the form, okay, form of the state vector and the form of the input. So we do the comparison. Our x dot t actually equal to dvct over dt. Our a actually equal to negative 1 over rc. xt equal to vct. b equal to 1 over rc. And ut equal to the vt. So now we already get the x dot t equal to xt plus but. Okay, so this is the explanation or the comparison between x dot t equal to x plus but, and this is the parameters that we obtain from that. Okay, so as long as you understand the step how to solve the question, I believe you can do the modeling. Firstly, you need to have this table, and then based on the table, you read the equation carefully and see what is the state variable and what is the output. Okay, and then after that, you highlight the formula that you must use. Okay, after that, after you highlight everything, then you do the shortlist the formula. After you do the shortlist of the formula, then you do the KVL equation, find the KVL equation. After that, you find the KCL equation. After you have KVL and KCL, based on the formula, information, you must replace the equation. The KVL equation must contains only your state vector parameters only. Okay, accept the input and accept the resistor, capacitor, and inductor value. The others that parameter that varies by time, you need to replace them with the state vector parameter. After complete Then you need to rearrange the equation that you obtain, in this case, equation number 6, into the form of the x dot t equal to xt plus bu t. That's the answer lah. That's the step. So the rest that we not complete yet, our yt equation lah, output equation. Based on the question, the output is the current, is the voltage across the capacitor. Is the voltage across the capacitor actually. Voltage across the capacitor. Alright. So we have the equation yt equal to vct. Okay. So we need to compare with the state space equation yt equal to cxt plus dut. So finally we get our state space equation for the RC circuit. This is one. So this is. So if you can see that, why we can confirm that this is the first order of the equation, first order system, since you have one only equation here. So later on, I will show you what is the difference between the form of the first and second order system. Okay, so far, do you have any question?
Doctor,
Yes.
can you explain again how can be C equal 1 and D equal 0?
Okay, yeah. All right. Based on this one, based on the equation, based on the question, based on the question, the voltage across the capacitor as the output. Okay, the voltage across the capacitor as output. So we translate this information into an equation. So based on that, where is it? Okay, so this is voltage across the capacitor as the output. So that line I translate to the equation. So based on the state space equation, yt equal to cxt plus dut, right? Okay. However, our equation here, yt equal to vct. So I just put it here. Yt equal to vct lah. Alright. So why I say that d equal to 0, ut equal to 0, because yt only equal to vct. Because there is no others thing here. Okay, because yt only equal to vct only. So that's why in order to get yt equal to vct, so we must put d equal to 0. Because 0 multiplied with the vt will equal to 0, is it?
Yes.
So there is no others than yt equal to vct. Is it clear? Why d equal to 0 in this case?
Yes, yes, Doctor.
All right, thank you. Thank you for the question. All right, is there any question before we take a break and we'll continue at 11 a.m.? If you have any question, please let me know. If not, we will continue at 11 a.m. So I need to stop the recording to make sure everything in 2 parts. Stop presenting.